Okay. Hello, everyone. Here are Lacey, Sean, and Celeste, Gilda. Um, First, I would like to see any questions you have, so I can take care your question first. I think that's more important, right? So, anyone that you would like to share your problems, questions from the homework, or from even, yeah, even the quiz questions you can ask me. That's fine. So anyone, would you like to share?
I have one question.
Yeah, sure. Good.
Um, while reviewing on chapter 9, the null and the alternative hypotheses examples that
Yeah.
are in the book,
In the
there,
discussion. Yeah.
yeah, well, this one's in the book.
Oh, in the book.
And yeah, and that one was about the cholesterol medication. It said that, oh my gosh, I want to repeat it to you.
That's
um,
okay. Try to understand the problem.
because even I get confused. So
Uh,
the question was that in the medical trial,
okay.
the researchers were saying that the cholesterol medication reduces. They are trying to prove that the cholesterol medication reduces cholesterol by
Mm-hmm.
25%. So
Mm.
they don't say that the cholesterol medication reduces cholesterol by more than 25% or less than 25%. They
Mm.
also don't say that so because of that, I
Yeah.
thought that it would be the null hypothesis would be p equals 0.25 rather than p equals or p would be less than or equal to 0.25 because of the wording. So
The
that's where,
wording. Yeah.
yeah, so that's where I'm confused.
Mm.
Should it then be that the null would be p would be equal to 0.25, and then the alternative would be p does not equal 0.25, because they're not saying that it's more than or less than the
Mm.
25% likelihood to reduce the cholesterol. So that's where I'm a little bit confused. Or should it be, more than 25% reduction in cholesterol?
Right.
It's
Well,
just the wording, so I'm
yeah.
confused on that.
The rule, I know this is very confusing when we come to the hypothesis here.
Yeah,
The null hypothesis, keep it this way. The null hypothesis always will state equality and always
right.
equal. And
Okay.
the alternative HA is the one
Yes.
we need to put the less than or greater than.
Right.
No equal sign on the alternative. Okay.
Okay, right. Well, so that part I get, but what
Oh,
I didn't know to do was how to understand the wording. Because
um,
on the example, I want to just read it
is
on
that the
the
example? I'm going to open the book. So,
yeah, it's in the book, and I want
yeah,
to pull up
the which section?
it's section 9. It's the example that is called 9 point medical trial. Okay, so it's the one that it's example 9.1, and below it says try it 9.1. And so,
9.1. Okay.
yeah. And so in the example 9.1, it says the null is no more than 30% of the registered voters in Santa Clara County voted in the primary election. That would be P is equal to or less than 30%, 0.30.
I can open the book now.
Oh,
So
okay,
let me
sorry.
share the book. Yeah, share.
I think
And
it's page 476.
because it's a textbook, so everybody kind of got a different page. But it's
Oh, that's true. Yeah, I have
yeah,
it on PDF, so
I
I don't
know.
know.
So I have to see it's example or whatever. Then you say example under 9.1. So we can,
Yeah, under 9.1.
yeah,
Yeah,
so we
that's
can
the very
find,
beginning.
yeah, good.
Oops, I think
I
I have it.
find it. So did you see it now?
I see it. Yeah, it's right there. So that one, I understand where it says example 9.1, but below it where it says try it, that's where I got confused because where it
Try it,
says,
medical trials
yeah,
takes whether or not a new
right,
medication reduce cholesterol by 25%. Oh,
yeah,
this one, because they said whether or not, okay, that means could be yes, could be no, right? So that's including the
right.
two things here. Could be
So I'm like,
greater, yeah, or could be
so
less.
is that could
Yeah.
be, yeah. So could it be, so does that mean that we're going with greater than or equal to
We need
20?
to use the alternative, like example 9.2 there. Look at the 9.2.
That's what we're using. Okay,
Yeah,
okay, I see it. Okay,
yeah.
so equal to
And not
that,
equal to. Put the not equal to. Not
and then
equal
not
to.
equal to.
Yeah,
Okay,
that
got
means
it.
could be or could be not.
Yeah,
Yeah.
got it. Okay, that's where my confusion came in because at
Mhm.
first I was trying to go by the one above it, but I was
Yeah,
like, that can't be right because they're not really saying more than or less
I
than
know.
the 25%. So it's like,
Yeah.
it's a trick.
Yeah, very tricky. Yeah, that's why
Very tricky.
we need to practice this kind of statement. The example
Right.
you point out that you try it 9.1, it's the tricky one.
Yeah.
That's why it's
Yeah.
the alternative. You have to put the not equal to. Okay,
Yeah.
0.5. And
Okay.
HO, no hypothesis, just put the equal 0.25. Okay.
Right. Because
Yeah.
that's right now what they're saying. That's the status quo right now. That's
Uh-huh.
what's happening. Okay.
Right.
I understand that part.
Very good.
I'm gonna
Uh-huh.
highlight it. Thank you.
Yes, I like that.
That was that was my question.
Very good. Very good.
Thank you so
Good
much. Thank
question. Yeah.
Yeah. Thank
And
you.
that's very easy to get confused.
Oh
So,
yeah.
yeah. Yeah, when I was a student, I always confused by this kind of statement. Ah, should I put less than or greater than or not equal to?
Yeah, you have to read it like 10
Oh,
times. And
yeah. Uh-huh.
and then you question yourself and then
Uh,
I don't know, then you have to walk away and come back and try it
yeah,
again.
think over again. But if you keep the principle
Okay.
that when the statement including the equality, equal, that's always they put out as no hypothesis. If the meaning including could be or could be not, then we put the alternative. Because only
Got it.
alternative accept the three symbols, greater than, less than, or not equal to. Okay.
Right.
It's
Okay.
only for alternative, HA. Okay. Good. Any other question? Everyone who are here today, we are smaller group, so we can answer your question one by one. So look for your homework or your reading, like Gilda read this one, and this one is really confused.
I have a question.
Sure, Sean. Yeah.
So this is for the
Chapter 9.
discussion.
Oh,
Yeah, the week 9 discussion, the last yeah, this is
weekly.
chapter 8. And
This
I was just
chapter
looking on
8.
the second video that you
Okay.
guys that we had, the
That's
population proportion. I'm gonna share my screen.
Sure, that's better. Everybody try to find out where you are and share so that the way we know exactly what's the problem there.
So
Chapter 8, week 8 discussion. Yeah.
yeah. So this one right here,
Oh,
this video,
yeah.
you see my screen, right?
Yeah, I can see it. How about it?
Where do you get the 99% confidence mean? So that Z number,
Oh,
I don't know
oh,
where that came from.
oh,
And I
that's
got the
the
P hat, the Q
score.
hat.
no, because when we do confidence interval or hypothesis, we always have to state how many percent of the confidence here, especially for confidence interval. You always have to make a statement how many percent we want it to be confident. So this problem is to say we want 99% of the confidence here. So that's why they just predetermined I want the 99% confidence. Then we need a critical value, not the G with that symbol, how you call that, like a small star there, right? That one is trying to show critical value symbol for this author who make this problem. And some book they use G alpha divided by 2. Okay, I think you have seen that kind of notation. But this one here they use a G and with some small star at the side there is presenting critical value. For some textbook they use that symbol. So that the number 2.575, how we determine that? It's some book they already attach that critical value for the student to use because 90%, 95%, 99% is three confidence level very popular. People use all the time. So some book already point here show the critical value. You know, critical value is the boundary where we bounding our confidence interval to present from what number to what number. Another boundary as a critical value, just like a boundary, okay? Because if you say 99%, okay, then from which number as our boundary here? And that 2.575 is the boundary, okay? So it's just like you think of like a critical value, like a G score. You can think of the G score as in the middle is 0, okay? And then we have 1, 2, 3. G score as 1, as 2, as 3. If you look at the G score table, they divide that way. And that 2.575 is more than the 2, right? More than G score as 2 and close to the 3, but in the middle, 2.575. And the left-hand side will be negative 2.575. That just serve as the critical value as the boundary. So this problem is ask us to estimate the percentage of the household which vehicle is owned. So they want the 99% confidence. Okay. That your sample percentage is a margin of error of the 3% point. Okay. So that 2.575, how can we find this? You can either use a graphing calculator or you can use a G-score table. Have you been using a G-score table? The end of the textbook, we have G-score table, okay? And it's a link they provided there. Or you can just go to the Google, okay? Google one G-score table, so you can see that the number. So let me show you where you can find. Let me go to the google.com, okay? Go to the Google. And you can just type in, I want the G-score table. And it will pop out for you, okay? So instead of going the back side of the book, searching for that link and print out that table, you can just type in G-score table. Okay, so let me share with you. Share. Okay. So I want to share. No, not this one. Stop. I want to share the one with the G-score table on the website. Share. Okay. So now you should see the 3 G-score table here, right? Don't use the inner one here. I don't like the inner one here. I will go down. There's one more better from some university that posted here. Not here. But there's one gtable.net. There's University of the Arizona. Arizona is using a cumulative. No. There's so many here available on the website. And let me see. University. Let's see, pop out something or not. No. Yeah, I think this one. I want the this is Arizona, Texas. So many schools they put it there. But I found that this one is better. University of no, let me check this one. But it's not this one. Okay. No, not this one. Another one is better. Let's go to introduction to the G table. Okay, statistical liberal test. This is the OER 312. That's presenting how you read the G score, but still not too good. Let me find another one for you. Maybe let's try this one. Okay. The G table. The G table, we have positive and negative G score table. Positive one, yeah, this is good. This one is help us to read. They post the negative first. Negative G score table. That means any type of the data minus the mean divided by standard deviation. That's how we got the G score. In chapter 6, presented that, how you have the G score. So once you have G score, you can always come to the table to read the probability and the critical value. Okay. So the critical value is reading inside this number first, the area, the probability. Then we see what's the number bounding that. The G score is like a boundary. Okay. So how can I find that? That the 2.575 is here. 2.5 is here. Okay, 2.5 and 2.575, 2.575, 2. So 2.5, you have to match with under the 0.07. You can see 0.07 is there. So under the 0.07 and with the 2.5, you will find a number 0.99. The area is 0.99492. Okay. But we need to find the other way around. So, and this table is give you the 5 decimal. Wow. 5 decimal, it's okay, but it just need one more number of the computation. So how I found that? Okay, let me use the, I need to draw some graphics to show you why. Okay, so I'm going to draw something on the whiteboard. Let me find my whiteboard. That. Okay, whiteboard pop out now. Microsoft whiteboard. Okay. I have used this one for the past section we did. So I'm going to look for one new one. Okay, new whiteboard. New whiteboard. Okay. So whiteboard will show better idea here. So this is the horizontal line, and our proportion of the G-score with the segments given is a construct a normal distribution. And that the problem is doing the survey of the 99%. So our 99% is in the middle, okay? Is here. Here in the middle part is 99%. It's right there, which is the same as 0.99, okay, as the area. So if I change this 1% into the decimal, it's 0.99, right? And we are looking for boundary on the right side, left side, to do the research study of the confidence interval for the estimation, right? So that confidence interval is bounded here. And this boundary, two sides, is the G-score, okay? That's we call critical value, okay? This point and this point here to bounding our confidence interval here for 99%.
Hey, Professor, I can't see your screen.
Oh, you can see. Let me stop and do again. Okay. Share here. Share. Can you see it now? My whiteboard?
Yes.
Okay.
Yes, thank
That's
you.
what I try to show you. 99% of the confidence survey here. And G-score, we're supposed to be finding the boundary, not the red color there, bounding this interval here. So I'm going to write the notation. So the notation, actually, what we are doing, usually we are writing alpha divided by 2. Alpha divided by 2, like, not the, I put a small a, but actually it's alpha, okay? From the Greek, alpha divided by 2. Alpha is a significance level. So we use this symbol. But this book is using, who created this problem is using the G with asterisk, this symbol like that. So both notation means critical value. It just means critical value. Critical value. And the purpose of the critical value is try to make a boundary for the confidence level we are looking for estimation. And so for this one, how can I come out the 2.575? You need the area to the left to read that, okay? So understand our alpha is no. First, we have to understand the notation of the 0.99 is a confidence level because confidence level CL, I think CL. When you look at your TI 83, 84, they put the CL there. That's confidence level. So our confidence level is 0.99, 99%. So which is not the confidence level, that's what we call significance level. Significance. Significance level, and which is in statistics we use the Greek notation because the Greek is the country they started talking about statistics 200 years ago. Okay, so everybody just follow their notation and they use alpha. Now the alpha is look like that small a I put there. Okay, look at small a, but it's not really a. Okay, it's kind of like a you do that. I have because My whiteboard doesn't have that kind of notation, Greek notation. So I will just write with my mouse like this. That's alpha. And we call alpha significance level. So alpha area is equal what? Alpha is equal 1 minus 0.9999. Subtract out in the middle, that's the confidence level, right? To refill the probability that we are going to present here. So the remaining is a point, 0.01. You just subtract from the 1. So alpha is including right tail, right? We call right tail area here. And the left-hand side, this area here. So that's why our book notation, usually we use G and make the alpha, small alpha, and divide by 2. Usually we use this notation, okay? This is more accurate notation. Use a significance level divide by 2 for this point here, critical value, okay? So we have 1 on the right side and 1 on the left-hand side. And the left-hand side, this point will be negative, the critical value, G alpha divided by 2. Okay. So now we come to the point. You can see the area is alpha divided by 2, okay? Reflected to this point position here. So you take alpha divided by 2, which will give us 0.01 divided by 2, and the answer should be 0.005, right? So the area to the left of the G score, if you look at the left-hand side, this one, this area is very small. It's just 0.005, so small like that. So once you recognize what's the area to the left of the certain G score, you will be able to read. You will be able to read our G score here, bounding this area here. So our G score table will help you to do that, okay? And if you want to get a positive, you have to take a 0.99 in this area, 0.995. So the total area to the left will be 0.995, right? And when you come back to our G score table here, this G score table here is using a 5 decimal, okay? So we will just, it's okay. We can pick up the 2.5 and 2.6, these two numbers. Some table they will divide for us because we are looking for in between, okay? We are looking for the area 0.99, 0.005, or you can use the area 0.005, adding in the middle, not the 0.99 together. You adding is the 0.99 together. The area to the right-hand side of the critical value will be 0.9999 and 5, okay? And you can add one more 0 here to make a 4 decimal. And then go back to our table, G-score table. If you can go to the website, click on google.com there, Google, and search for one G-score table. That would be helpful for you to understand. So I'm going back to G-score table, then later I will come back here. I go to the G-score table. I will looking for a table which is using the 4 decimal is better. This is too many decimal. Okay. Okay. I think this is better. When I found the right one, I will show you. This is not a good one. This morning I found a good one, but no, couldn't see it. These G-score tables, just type that only. Anything. Okay. In the our course, I have copied the one good one for you. Why don't look at that one? That one is easier to understand. If you go back to our course, okay, Math 160 there. I think I put the G-score table there under the announcement. I check from there. Announcements and how to use the G table. And I should have attached the G-score table.
Professor Renita here. What's happening is when we click on, well, when I click on the links for some of the tables, it's saying access denied.
Access denied. Okay, sorry for that. Sometimes they just didn't want to post it. So I think I need to post again, make a new posting. So let me see, let me find out from my file. I will post a new one again. So the one you try to look at, you cannot see it. Okay, let me open mine. Well, it's good that you asked question today about the critical value. Otherwise, I didn't know the link cannot be opened. Let's go to, okay. Math 160. Here. Okay, almost came out. Okay, I found the one. All right, I will post this one at announcement again. Maybe that one they closed it, didn't allow us to post. So that's why I say not accessible. But maybe stop share, okay, and share again to show you the table. So the table is this one. This one is originally I posted under announcement there, okay. This is a negative G-score table. And this is very good to show you the critical value in between. And that one, 2.575, you see, is here. The area alpha is 0.005. That's the one I tried to show you how you find it. You need to find the area of the significance level alpha, and that alpha is just take 1 minus confidence level, then divide by 2. And divide by 2, we got the 0.0050. Did you see the button at the left-hand side corner here? Shows 2.575. That's the number came from. Okay. Did you see that number, Sean?
Yes, I see it.
Okay. And that the number is coming from, this is a very special value, okay? For the 99% is a special value, come with a 3 decimal. The most of them is 2 decimal only, but for 99% confidence level is 2.575, okay? 3 decimal. And another one is 1.645, is for 90% confidence level. So you may write a note, because these 3 numbers we use all the time. 99% we use a 2.575, positive or negative, but usually we just ignore that negative sign, because each side, the absolute value is the same, 2.575. Right side with a positive sign, left side with a negative sign. The value itself is 2.575. It's in between. You look at the graph, our table here. It's here, the small star here show us is in between this value 2.5 is in between 2.5 56, the pick up in the middle, okay? Because the area we don't have, the table itself did not have 0.005, okay? They do have 0.0051. Then the next number is 0.0049. So therefore, traditional way, we just take these 2 numbers, these 2 areas, okay? 0.0051 plus 0.0049, add up together, divide by 2. That's come out the 0.005 of the area. For the left-hand side, the critical value area. So then we read the corresponding G-score, 2.5, and up is 2.7. So it's kind of in between this number 2.57 plus 2.58. We add up together and divide by 2. That's why they come out that number. Okay. So this way give you the explanation why come out that number. But actually we don't need to worry for how it came from. But understand once it's good. You know how to explain it. But you just need to take a note, okay, for the future use. When we need to find out the sample size, usually we need to provide the critical value to compute the sample size. On the exam problem or quiz problem, usually you need to have this number to go if you need to do the estimation of the 99%. So I will take a 2.57 plus 2.58 is in between. Then I divide by 2, 2.57 plus 2.58. Then divide by 2, and that's come out 2.575. We use these 2 critical value, 2.5 under the 0.07, the area of the 0.051, and the other one, 2.58 under the 0.08. Because these 2 areas add up together, divide by 2, give us the 0.005. That's traditional way we have to do that. Okay, kind of hardship to get here, and that's why they make it easier. That's why I like this table. They explain how we get this one. So for the area 0.0050 only, use this 2.575. For the area of the 0.05, use 1.645. There are 2 special numbers, okay? And for the right-hand side, just eliminate negative sign. Because for the G-score, it's always a negative, positive, opposite sign, but same value for the confidence level. And now I'm going to show you how to use your TI-83, 84 to do it, okay? This is traditional way. And use a calculator, sometimes we might have one last digit deviation here, 0.01 difference, because of rounding error, okay? The calculator always give you more decimal, and the traditional table, G-score table, they always round off. For the G-score, usually round off to 2 decimal. You can see first column is for 1 decimal, and on the top column is for 2 decimal of the G-score. Only 2 decimal, most of the time. Only these 2, they are special value, use 3, okay? So that's fine. Now let's go back to the whiteboard. And the whiteboard, I'm going to show you how you use the TI-8384, okay, to get this 2.575. But when we use the calculator, I think we'll give you 2.576. Then let's see. No, let me see. Let me go to this one, easier to type. Okay. So when you go to the calculator, you can place on second vowels, okay, second vowels, and I will use second vowels there and go to the inverse norm, okay, inverse norm. We are taking the inverse of the normal distribution. Before, we always use the G-score to find out the probability, right? Normal CDF can do for you. But if you know the percentage, you know the area, you know the probability, how can we find the corresponding G-score bounding not the area? You have to use the inverse. That's why inverse norm. Okay. So I will click on inverse norm, put the enter, then the calculator will ask you what's the area bounding to the left-hand side. The design followed our traditional table. Only the area to the left that we care to find out the corresponding G-score here. So for this problem, I will find out the left-hand side first. I will find out this one, okay? And this one is the area is only 0.005, just like the table we look for earlier, 0.005. And the mu, the area, I will put a 0.005, and the mean, I will put the 0 because it's a G-score. G-score always standardized. Use the mean. Whatever mean score will set up as 0, okay? And the standard deviation, right? Standard deviation is a sigma, which is one unit. Now, after you input the 0 and 1, you just hit the paste, right? Just paste. And after you've placed the paste, we pop out inverse norm. So if you use a TI-83, you have to type in yourself. You have to type in under the inverse norm 0.005, 0.005. But if you use a TI-84, they do for you. And the calculator will pop out the 0.005 confirm, and the 0 as the mean, and the 1 as the standard deviation. That you will see on your screen. Then just hit the enter, right? And when you hit the enter, my calculator shows negative 2.575. You see? The 3 digits is exactly the same as the table, because table they round off, okay? At 2.5, but the calculator give you more decimal. We have more decimal behind, like 829,303. If you use your calculator to do together with me, you should see this number, okay? But most of the time, we just round off using a traditional table that as a 2.575. But I saw somewhere our textbook shows a 2.576, okay? But when you use 2.575 or 2.576, doesn't make that much of a change. And we understand that that's just rounding off error here, okay? So that's how we got the critical value. And if you type in your calculator with area to the left for, if you type in your calculator inverse, that inverse norm, okay, go to second vowels and inverse norm. If you type in the area 0.995, okay, 0.995, use this positive G-score table, positive G-score area to the left, 0.995. If you enter the area as a 0.995, 01, paste, it will come out the positive one, will give you positive 2.575, and that's exactly you read that the problem shows that the video there shows that the number 2.575 for the G star equal 2.575. And the author of that questions, he also adopted traditional way 2.575. And that's fine. Okay. So most of the time we use a 2.575 because that's a traditional table we use. Is take an average of the two and come up with this number here. So that will help you to do your confidence interval. I think that the problem is for you to find a confidence interval, right? Estimation. So Sean, do you have additional question on this problem? And you know how to find out the confidence interval?
Yeah, that helped a lot on the calculator.
Okay, great.
To understand it more than
Yeah,
this
very
graph.
good. It's important to understand, right? So we don't keep on question, oh, why this is strange number pop out like this, right? So you look at the graph, that's what give you very clear explanation why. Okay, great. So on the right side is 0. The critical value is 2.575 positive because on the right side. And on the left hand side, this point boundary will be negative. Okay. Negative 2.575. And to find out all this number, the principle 575, you just have to know what's the area to the left. Okay, so if you enter the area to the left, it will pop out your G-score. So you use the inverse no. And I think for the chapter 9, you also, or chapter 8, you also have chapter 8, chapter 9, they are kind of related. Okay. Chapter 8, when we don't know population standard deviation sigma, you have to use a T interval. And T interval, in case the problem asks you to find out the critical value, you just go to second vowels and looking for inverse T. That will help you to find the critical value. And also, again, use the area to the left. But for the T interval, you need to enter one more number, degree of the freedom. What's the number of the sample size and subtract 1, n minus 1, df, we call df. Then we do it. Okay. And chapter 8, chapter 9, we deal with the G, normal, and G score. We also deal with the T interval, T score. We also have critical value, T alpha over 2. Okay. And for the hypothesis testing, same thing. Hypothesis testing, they tend to use alpha, significance level, because our hypothesis testing is testing the significance. It's people like to say testing hypothesis, proof or prove it is true. That's a wrong statement. We don't use proof here. We use testing the significance level. So alpha, if usually it's given alpha as 0.05 because that's a common use in the real world. And I checked with my friend working in the Boeing. She's working in the Boeing as a math scientist there. And I said, when you're testing as hypothesis here, they always have to assume something, then testing first. Then if testing goes through, then they can build out the model, construct an airplane equipment or something there. So she said, oh, we always use alpha equal 0.05. That's the common use of the significance level people use in the real world. So alpha is a 0.05 or 0.01 or 0.10. These three numbers we use all the time. And that's connected to our confidence interval. If you use a 99% confidence interval, right, then our alpha, our significance level will be the 0.01, right? So that remaining of the 0.99 confidence level become our significance level alpha. So in hypothesis, we use alpha, okay? But in confidence level, we count the confidence level, but they are kind of connected here. Okay. All right, so any other question you have? And for the confidence interval problem, you better use your TI 8384 to do it, okay? Because make it very easy. And for the proportion, much easier. You just enter the success number and the sample size number and CL, the confidence level asking you to do 90% or 99% or 95% or 82%, something other number. It's okay. Calculator will do for you. And will pop out the confidence interval inside the parenthesis. And you can present as a parenthesis, or we can present as an inequality, right? Put the alpha, put the p, small p in the middle. That's for proportion. And for the mean estimation, I will put the mean, the mu in the middle. Then put the lower bound, upper bound in between. You have two ways to present it, right? And you also can use estimation, the best estimate, which is the S bar for the mean, or P hat for the proportion. Then do plus or minus. Other part is the modular error, right? That part plus or minus to do adjustment to come out that lower bound and upper bound. So actually we have three ways here to do the confidence to present the confidence interval. But the easiest way is using your TI calculator. Okay, we just give you the answer directly. And any other question you have? Very good. Today, Yuda and Sean, you all ask good question here. Any other person, do you have question from your homework? You can share with us. Okay. So you're studying chapter 9 now, right? This week? And let's see.
Just started.
Just started.
And our homework is not due this Sunday, it's due, looks like on the 27th.
Okay. Let me
Is that
see.
correct? Because normally it's every Sunday, but I saw that it said on the 27th. I just wanted to be sure.
Okay, let me.
The discussion looks like it's due this Sunday.
Oh, discussion. Discussion
Yeah.
usually due this Sunday.
On the 20th, I think. But then
Okay.
I think the homework assignment says the 27th.
Homework, chapter 9. Yeah, chapter 9, 27.
Okay, that's good, actually.
Yeah, you share.
These are longer.
Yeah, you can ask questions and solve the question, or
Right, it's a lot
some
more.
people they post some solution there and then something.
Yeah.
Then you do your homework, or you can post your homework question. Okay, you can copy and paste. We found that this program, my Open Math, allow you to copy whole thing. Okay, and paste to our discussion here. So you can copy paste into there with your own solution. Is okay.
Yeah.
So
Yeah.
that's even better. We wanted to know what's the right way to go, right? And compare with what's the common mistake here. So
Okay.
copy and paste, and don't afraid that you have some wrong solution there. That's good. Okay. And copy and paste. That's the easiest way. For example, if you, but let me see, chapter 9 homework. Let me open up. And I look at some questions here. Okay, let me copy and paste one. Okay, so I'm going to copy. Oh, doesn't allow me. Okay, What's happened? Because it's on the website? No. Okay, let me try again. Highlight everything, right? Copy, Control C. Then I'm going to the discussions there. So I leave here, go to the discussions. And later I will share with you. So I just copy my assignment from the chapter 9. And I go to the week 9 discussion here. Or week 10, maybe week 10. Okay. And week 10 is for chapter 9. Yeah, chapter 9. Okay, so that's the right place. So I'm going to click on reply to be able to post something. So I just Control V, paste to here. Okay. So I just did. Okay, I'm going to share with you. And I'm going to stop share that one and share this one now. So I'm going to share what I copy and paste from the homework assignment into the discussions. Share. I just copy, okay, highlight all, Control C, and bring to the discussion board here. And I click on the reply, and I put a Control V, paste. So you can see here, question 8 is right there. Okay? And I will make the due date, due date is 16 today. I will make a maybe longer day for you. This one here, you see, I just copy and paste, and it came out not the right order here. Oh, the choice. The first pair, I think it's the first choice, second pair, third pair, all the different choice here. And the questions ask you, the test is right tail test, two tail test, left tail test. Okay. Based on sample 25. Okay. I think this following is asking, first, make a choice of the null hypothesis and alternative, right? And test the claim that the GPA of the 9th student is smaller than 2.5 GPA at the 0.025 significance level. So they ask us, what's the right null and the alternative hypothesis should be? So we can try out this one, right? The question, the claim is focused on the GPA of the student is smaller, okay? So when you see smaller and less than, that you have to go to the alternative, okay? So alternative, and let's see, GPA is the mean. You will not choose the P. P is for proportion, percentage, okay? So I will choose the one pop out with the mean, the mu. And the one come with a less than for the alternative. So some problem they use 0 and 1 as no hypothesis or alternative. They use the computer binary because computer language is either 0 or 1, 2 digits only. That's why running so fast. Okay. So some author they use 0 for the no hypothesis and use H1 for alternative. So I was looking for alternative H1 with less than, right? Less than. And look like the bottom one is the right one. H1 alternative mu is less than 2.5. That's the one I wanted to test in here. Then the null hypothesis will be another choice, right? Greater or equal, you can put it there. Actually, you put the equal is correct already. But traditional way, like the 8 that greater there, it's okay. But for the modern way, you can just put the equal, okay? HO mu equal 2.5, that's correct already. If equal, of course, it's greater also, okay? Just against our choice of the H1. So H1 is only less than. So the other choice against the less than 2.5, of course, could be equal or could be greater 2.5. Okay. So when you write no hypothesis or alternative, always start from from the alternative first is easier because that's the claim coming from. When the claim smaller, I will just choose that. Okay, alternative H1 must be smaller, less than. Then the other one, H0 greater or equal, must be right. So the last one is the right choice. And let's see, what do they want you to do more? Oh, to ask you, this type of the test is a right tail test, two tail test, or the left tail test. And when we decide what type of the test is based on the alternative, okay, remember, it's based on HA or H1 alternative. So alternative says less than. So that's one tail. And that's the one we call left tail. Because less than, you go to the left-hand side. Kind of based on the algebra. Less than the 0, go to the left. Greater than the 0, go to the right. Okay. So will be left tail test for this one. Then the next one is asking you, based on the sample of the 25 people, the sample mean GPA was 2.47 with a standard deviation of 0.05. Oh, what's the p-value? Okay. And for this problem, because the problem did not mention anything about the population standard deviation here from the beginning to the end here, I don't see anything of the sigma population standard deviation. So we had to use a t-test, okay? If you don't have the sigma, use a t-test. So for this problem, I will go to my calculator and place on stat and go to the test, okay? And choose the t-test, the number 2 t-test. So you place on the t-test, they will ask you input, is it data or stats? I will select the stats. When you choose the data, only the problem give you the original data. Okay, if they say, oh, 25 students, their GPA is 3.2, 2.5, 2.1, give you original data, they use the data. But if not, they say, sample mean GPA, well, that's an X bar. So if they give you X bar, you have to choose a stats, okay, statistic. So I will place on enter to confirm I want to use a stat. Then you just continue go down to change that the null hypothesis, mu 0, right? Or the mu O, you can read as the mu O, null hypothesis of the mean. What do we do? And for this problem, we are testing less than 2.5, right? So the testing number is on the top, that's the number there, 2.5, okay? So the calculator, you have to put a 2.5 for the mu with a 0, okay? And go down, X bar, enter that number, 2.47, and XX is a sample standard deviation. It's given 0.05. So I put the 0.05, and sample size is 25 students. And going down, you have to choose the left tail test, the second one. Second one is less than. And to confirm this, you have to hit the enter, okay? Then go down to calculate, enter, it's done. The p-value is 0.0031, right? You do together with me, you should get the correct now, 0.001. And they say, well, p-value is, they want to round it to 2 decimal. Yeah. You round it to 2 decimal, will be 0.00. That's because the third decimal will be 3. Okay. So that's how you do with the t-test. Okay. So very good. Today you share the question with me, and that's where we can see exactly what is your problem is, and I can give you the better help here to show you and explain to you what exactly what we needed to do. Right now, any other one you got questions? If not, I will see you next time, right? And always you can copy and paste your question like I show you today. I just copy and paste, put it into the discussion board there. Okay. And you just say, oh, please help me this one. Just that. Okay. And some
Thank
people,
you.
yeah, I come to help you, right, everyone? Okay, you're welcome. And
Thank you. Good night, everybody.
yeah, good night. It's 6 o'clock already. Yeah, bye.